Welcome to my study material for ethical hacking. This is chapter 8, web service hacking, web application, as well as database attacks. Now keep in mind this is just a quick, brief overview. This is not made to be an in-depth, here's everything about it. This is more of a just get your feet wet a little bit. So in this chapter we're talking about identifying components for a web infrastructure, looking at how to scan a web server, how to identify a web server's vulnerabilities, explain how web application hacking works, describe web-based authentication, describe web-based password cracking techniques, as well as some SQL vulnerabilities. So here is a common example. We'll have a web server front end, and we'll have some form of attacker with a web browser. He's going to be communicating with our web server over HTTP, over SSL. The web server is going to run different types of web server software. On the back end, it will have web apps, which are coded in different languages, compiled or stored in a database, which again have its own languages. And so our exploits can be at multiple different levels depending on what we're going after. So a web server attack, we could be looking at just HTML or the HTTP because those are the major two standards that originally defined our web architecture. HTTP did have 4 stages, and the web attack mainly focuses on things such as scanning for web server operating system or web service, the actual software serving the web pages, maybe banner grabbing. We're to then move on to tagging the web server, maybe even surveying the applications, because maybe we don't want to attack the web server, we may want to just compromise a specific application. Or we can start targeting authentication. Lastly, end goal may be the exploit of a database. So, funny little interesting story. We used to take care of a payment company. And one night, someone was able to breach the web server that served the database backend. So they actually left the web server alone, they left the authentication alone, and they actually was able to find an exploit in the database that allowed them to gain access. And it turned out they were able to wipe several payday loans because they had a direct exploit into the database. So scanning. Scanning could be looking at what open ports that are there. Are we looking at port 80, port 88, 8080, 8080, 88? I mean, all of them serve specific functions. And again, we've already looked at several scanning tools like Nmap and tools such as those. For banner grabbing, it'd be like Netcat or Netcraft or even Telnet. All of that's there to help figure out what web server they're running. Are they running IIS? Are they running Apache? Are they running a different form of web server? Because each one of those will allow you to figure out the vulnerability for that web server. And there are several websites that are out there that explain the vulnerabilities for specific web servers. Here's just 4 common ones. Security Focus, I get a lot of information from. Packet Storm Security, same thing. The interesting thing here, though, is you can say, I'm looking for IIS version 8 or IIS version 8.5, and you'll be able to get vulnerabilities specifically for that version of web server. For example, things like IIS vulnerabilities. IIS happens to be known to be vulnerable to things like buffer overflow attacks. And again, you can look at the IIS API DLL buffer overflow or many of the other overflow attacks, these sites are going to give you detailed specifics of the vulnerabilities in IIS. So a common question is, why do we have websites that show about the vulnerabilities? Well, the websites are there to show what vulnerabilities are there so that we could secure them. If we don't know about them, we don't know how to protect against them. So things with IIS, a big thing with that is for best securability, we're looking at things like hardening, patch management, getting rid of a lot of the disabled services that we don't need, lock down the file system, make sure we're using NTFS, and enable file level security and encryption, logging and auditing. They're all pretty straightforward. But the big thing here is recognizing the vulnerabilities that are there so that we can then figure out how to best protect our equipment from those vulnerabilities. Without knowing them, it's hard to figure out how to protect against them. Other web application attacks could be invalid input. That's always a good one. So it's expecting a username and you put a phone number. Does that work? It's expecting an email and you input a phone number or something else. What happens? If the website is coded correctly, it should continue to function. If the website is not coded correctly, well, the input may cause weird reactions from the web server. We could also be looking at parameter or form tampering. It's expecting a username, and you try running SQL code in it. Also, things like injection. You can inject code into a website. Basically, it allows for untrusted data to be executed as if it was valid. Whether you're injecting into the website or the website is injecting data into your PC once you've navigated there. We could be looking at things like SQL injections or file injections, XML injections. Those are the big ones. Moving on, it could also be cross-site scripting, XSS, as well as the site requests foreign attacks. Basically, this has been a more popular attack. It basically allows hidden fields, with the XSS attacks, it's essentially, again, another type of an injection where we will inject malicious scripts into an otherwise trusted website so that it will run the script when you run the website. After that, hidden file attacks, again, this is going to be similar to injecting code, but this is going to be injecting maybe other specific hidden fields like additional items in a shopping cart, modifying amounts in a shopping cart, not realizing it, things like that. So let's move on to web-based authentication. Common types of authentication. If we're using a basic form, we could be using something like exclusive ORing or XOR. This is weak from encryption. Very easy to compromise, but it's something. We could do a message digest like an MD5 algorithm hash, a certificate-based, or even a user or a form-based in the form of cookies. Those are all very common forms of web-based authentication. Web-based cracking. We've already talked about password cracking being like dictionary or hybrid or brute force. But if we're doing it online or on websites, we have some specific tools like OB1 or WebCracker. They essentially do the same thing, but for web-based. Cookies, that's always a good one. A cookie store information about preferences, usernames, passwords, content, and we could actually look at that cookie detail by looking at something like a Cookie Spy or Cookie Digger. That will show us some of the details there. A URL of I can never pronounce that. Obfuscation. Basically, it's hiding addresses in a URL, so we could bypass filters. That way, if we did have a filter that was blocking out IPs, we could get past it. Basically, this allows us to encode the data so it's not easily viewed. Common encoding schemes could be like hex or HTML or base64 or Unicode. That all allows us to hide additional information in URLs. So what was the point of all of this? Heavily, this is about intercepting web traffic or being able to bypass filters with the form of web proxies. These proxies allow attackers to attack and debug web applications, as well as bypass filtering software. It can be in the form of even acting like a man-in-the-middle attack. We funnel traffic through a specific location. At that location, if it's compromised, well, yeah, we have a burp proxying, other forms of proxies as well. Again, proxy is a way for us to go from our internal system to a different system and to be able to browse through that external system. So let's say our current admin locks out content at our location. Well, you can actually browse a proxy and then from that proxy browse that material, because you're not browsing adult material, the proxy is browsing adult material. Moving into database, database types, it could be a hierarchical, network or relational, even object-oriented. Common ones are going to be very heavily network, hierarchical, or relational database, though most times we're dealing with related data, so a relational database management system, or RDMS, very common. So when we know what type of database we're dealing with, we could then compromise it a little bit easier. Again, what type of database software is being ran? Is it Oracle? Is it Microsoft? Is it MySQL? Each one is going to have specific ports tied to their specific vendor. Now, all of this is going to be dealing with SQL injections, and that's where the attacker takes advantage of insecure code and sends an SQL statement into the database to execute or run. These are one or more of the most common types of attacks for databases. We can have things like a simple SQL injection, a union SQL injection, error, blind, you go through the tools. Essentially, the goal here is to interject code into the database so that the database runs the code and then executes whatever is in that query. That's actually it for this chapter. Again, by no means is this a detailed overview. This is just a very top of the mountain type thing. I want to thank you.